Okay, this means the limit of the function as x approaches a is L. So if you see that written in your textbook, on your assignment, that's how you interpret it. I know it takes us a while to really kind of understand how to interpret certain things mathematically, but that's what it means. Now, something that we have to get straight is this. The x is the inputs. So as the inputs get closer to A, the output is the limit. Are you okay with that? Well, let's look at an example so then we can kind of figure it out. Take out your calculator. Let's look at example A. You're going to see some exciting stuff today. There's going to be a couple of Mean Girl references. It's going to be good times. So 0.5 x squared minus x plus 3. I'm going to graph it. Zoom 6 standard. I get that kind of a shape, a parabola. And we want to find the limit as x approaches 2 of this function. Okay, we want to identify what the limit is. We're introducing the idea of limits today. Kind of seen the idea introduced already with our slopes of tangent lines. That idea of trending. What are the values trending towards? Well, let's do this. We'll type in trace. And currently, what is the x value? Am I close to the value of 2 yet? Not really. So let's move so we're getting closer to 2. Okay, now I'm getting closer to 2, right? Watch what's happening to the y values. The x is the inputs. That's what I'm approaching. The limit is the y value, the output. I'm closer. Closer. Pretty close, huh? So as x gets really close to 2, what do you think is happening to y? It's getting close to 3. Yep, and we could go from the other side. Okay, so I'm going to go all the way past, so I'm at 3.1 now, and now I'm going to approach from this side, and I'm going to get close to 2.3, it's at 3.39, 2.1, I'm at 3.1, and you can see that, yeah, it sure looks like y is getting closer to 3, doesn't it? And if you're not convinced, you can go to your table, and you can get close that way. You can type in 1, 1.5, 1.9, 1.99. And hopefully you're convinced that those values are going to a value of 3. And if you approach from the other side, 3, 2.5, 2.1, 2.01, 2.001, you can see that, again, it sure looks like you're headed towards 3. So as you approach an x value of 2, it looks like the y value is getting close to 3. Now, the fact is, that wasn't very hard to figure out because we could simply just plug in 2. You plug in 2, you get 3. 1/2 times 2 squared minus 2 plus 3. I would get 4 times 1/2 is 2 minus 2 is 0 plus 3 is 3. If it's a nice behaving curve, you can simply just plug in the value you're approaching, and that's going to give you the limit. No big deal. Look at B. What does the graph of the square root of x plus 4 look like? Shifted to the left 4. So I draw it. Does anything crazy happen at 0? No. So we can just plug in 0. 2, right? No big deal. Look at C. C and D are my favorite examples. I love them. I wait all year to get to teach them. Yes. What are we approaching for C? We're approaching 3. Can you just plug in 3? No, you can't. What can I do first? You can check out the graph. You could take out an X. Let's take out the X. And what happens? The X minus 3's will cancel, and you're left with just the function X. What does the function X look like? It's a line, and if you plug in 3, you get 3. So you would say that the limit would hopefully be 3, but let's think about the graph here for a second, okay? Let's punch in our calculator, because this is a graph that you have not seen yet before. And this is very crucial to your understanding moving forward. X squared minus 3x divided by x minus 3. Zoom 6. Now, your calculator is too stupid to be able to graph it correctly, but you look at it and you say, well, that's just the same graph as y equals x. No, it's not. Let me show you what happens here. For this graph, if I plug in 3, I get an output of 3. That's not true for this graph. If you were to go zoom, and instead of zooming standard, you zoom 4 as a decimal, you're going to see what's really going on here. What do you notice? There's a gap in there, isn't there? Because is 3 part of the domain? Are you allowed to plug it in? No. And if you press trace and you went up there, you can see that the values, I'm getting close to 3, getting close, almost there, nothing. There's literally a hole in the graph. So this wants to look like, it wants to look like the graph of y equals x, but it's got a gap at 3. And if you were to investigate the limit, if we actually looked at the values, you could see that as you approach 3 from that side, the values get close to 3. As you approach 3 from the right side, the values get close to 3. So yes, the limit is 3. But does h of 3 exist? It's undefined. There's no value for h of 3. You plug in 3, you don't get anything for the function value. So the limit can exist even if you can't plug in the number. And that's what we had last time, right? For example, I showed you guys this. Tangent of x minus 1 over x minus pi over 4. And you guys found that slope, didn't you? Remember doing that in your assignment? Turns out that when you look at this graph, every single time you look at one of the slope graphs that we looked at, this always happens. It's always a graph that has a hole in it. If you could simply find that spot, you found the limit and the slope. This is what makes calculus possible. Let's look at the next one. Next one's my favorite function. Anybody know what it is? Do I want to be in radians or degrees? Radians all the time in this class. Well, I can't see that very well. So I'm going to change my window. What is the maximum value of sine? 1. So I'm going to make this 1.1. The minimum value? So negative 1.1 we're going to go to. And I'm going to choose my x value as negative 5 and positive 5. Kind of zoom in on that, graph it, and I see that. See, for the last one, we were able to do some tricky algebra, weren't we? And be able to just figure out what the limit was. Any tricky algebra here you can use? Can you just plug in 0? No, none of that works. So you guys tell me. Maybe you want to take a guess for what the limit is? 0, I think, is a very good guess. But I would have to zoom in further to be really convinced. So let's zoom in. I would still say 0 might be a good guess, but I'd like to zoom in a little bit further. Oh boy. That I still can't tell what's going on. Oh boy. So I guess the graph doesn't really tell us a whole lot, does it? Like I can't look at the graph and truly know exactly what the limit is. I'm still confused. I'm going to look at the table. Whatever you want. Notes are optional. So I'm going to approach 0. What should I plug in if I'm approaching 0? 1, then 0.5, 0.1. So look at what's happening. It goes from 0.8 to 0.9 and then negative 0.5. Negative 0.5 again. Then back to 0.8. Then a negative 0.3. Does it seem like it's trending towards a specific value? The limit does not exist. We'll watch Mean Girls sometime. So some of you, when you get to this type of problem, here's what you do. Some of you will say, oh, if I'm approaching 0, I'll just plug in 0.0001, and it looks like, oh, negative 0.3 is going to be my limit. No, you're entirely incorrect. You got to look at what it's trending towards. And that will give you a better result. Flip it over. Now we're going to investigate what we call one-sided limits. You guys have seen the limit, as we talk about it existing, we need to come up with a better definition. So this means, for a left-hand limit, x approaches a from a left-hand side. And the indication that it's approaching from the left-hand side of the graph is this negative that sits after the number. So it's a superscript. It sits after the number, so to the right of the number. And here, this one has a positive. So it would approach from the right side. So you can have a different right-sided limit than a left-sided limit. Let's investigate this by looking at a graph right here. It says the function f of x is a graph to the right. Use the graph of f of x to evaluate the following limits. So what value am I approaching for a? Negative 4. Am I approaching from the right-hand side or the left-hand side? I'm approaching from the left-hand side. So I'm going to approach negative 4 from the left-hand side. Okay? So as the x values get close to negative 4, what are the y values getting close to? The y values are getting very close to 3. For b, we are going to approach negative 4 from the right-hand side. And as you approach negative 4 from the right-hand side, what are the y values approaching? Negative 2. For C, I'm going to approach negative 1 from the left. As you approach negative 1 from the left, what do the y values go towards? 4. and you approach from the right-hand side, the y value is going towards 4. So here, the limit is the same. Here, it's different. Can somebody tell me what is f of negative 4? It's 3. If you plug in negative 4, you get 3. Can somebody tell me what is f of negative 1? 4. Can somebody tell me what is f of 4? It's undefined. You don't have any value there. Let's look at the limit as x approaches 2. 2 from the negative. 2 from the left. What's the output go towards? Negative 1. How about 2 from the right? 5. What is f of 2? It is negative 1. Notice how these are different. Look at letter H. Am I approaching from the left or the right or both, do you think? If it doesn't have the symbol for left or right, it means you're approaching from both. In order for the limit to exist at that number, it must be the same from the left and the right. Because it's not the same from the left or the right, this limit does not exist. The right-handed side of limit exists, the left-handed side of limit exists, but the limit as a whole does not exist. The two must be the same. Which brings us back to letter E. It says limit as x approaches 4. There's no positive, there's no negative. So therefore, I must approach it from both sides. I'm going to approach 4 from the negative. What's the output going towards? 2. I approach it from the positive. What's the output going towards? So what is the limit? The limit is 2. Recall that you told me that f of 4 is undefined. You can have a gap there and the limit can still exist, which is what we saw with our slope functions over the previous few days. You're doing, go ahead, question. Yes, because as you approach 2 from the left, it's different than when you approach 2 from the right. Which brings us to that point. The limit as x approaches a of the function is equal to L if and only if the limit as x approaches a from the positive of the function is equal to the limit as x approaches a from the negative of the function. So if those both are equal to L, then the limit is L. But if one of them is different, then the limit does not exist. The right side must be the same as the left side. So we've looked at a graphical example. Let's look at an example using our table. Go ahead and take out your calculator and let's type in this next function. We have x squared minus 4 divided by parentheses x minus 2. I'm going to look at a table. What is the x value that we're approaching? In order to find the limit, I must approach from the left and from the right. If you're going to approach from the left, what value should you plug in? 1, 1.5, 1.9, 1.99, 1.999. What are you headed towards? 4. So the limit of the function as x approaches 2 from the negative is equal to 4. Now we have to check the limit as x approaches 2 from the positive of the function. What value should I plug in if I'm going from the positive? 3, 2.5, 2.1, 2.01, 2.001. You agree that it's headed towards 4? What if I actually plug in 2? Do I get a value? No. There's a gap there. There's a hole there. Now, yes, you can do some algebra here and factor this to x plus 2 times x minus 2 and cancel out the denominator and find out that the limit is 4. But that doesn't work for the next one, does it? So sometimes you have to use the table. So let's do the same thing again. Limit as x approaches 0 from the negative, and limit as x approaches 0 from the positive. We will type in sine of x, and we'll divide it by x. Whoop. And we go to our table. What should we plug in? We're approaching from the left. What do you think? Approach from the right. Just switch them to positive. 1, 2.5, 0.1, 0.01. Are they the same? So does the limit exist? It is 1. The previous example, they are the same. So the limit is 4. Go get some brain food. Come on back. We are almost done. And then you'll have time to work on your assignment. All right, we're done. Flip over. What about this one? The limit is x goes 0, 1 over x to the 4th. Do you know what 1 over x to the 4th looks like? You had an excellent college algebra teacher last year taught you what this looks like. Do you remember it? It's like that. So let's approach 0. We have to approach 0 from the left. We have to approach 0 from the right. Approach 0 from the left. What does it go towards? Approach from the right. Are those the same? The limit is infinity. This graph, again, because you had an excellent college algebra teacher last year, taught you how to graph that. It looks like that. That's what happens when you sit on your phone for half the class. All right, so let's approach 1. Approach 1 from the left. What do you get? Approach 1 from the right. Dunno. Does not exist because they are not the same. So this statement, the limit as x goes to a of the function is equal to infinity, in plain terms means this. As x gets closer to a, the outputs become extremely large. Okay. How do you speak about infinity? It's an idea that represents, yes, we'll have to perform this off for you. Yep. So, day before Christmas break, I will perform for you my song Ode to Infinity. Yes, sir. You heard a thing last year. Congratulations. That wasn't on purpose. That's because Rika Boersma and some other students came in to visit during that hour, and they begged for it. So I don't have my guitar. Okay, let's move on. We're almost done. If x equals a is an equation for a vertical asymptote, then one of the following statements must be true. Okay, if there's a vertical asymptote, then one of the following statements must be true. Either the limit as x approaches a from the positive is equal to positive or negative infinity, or the limit as x approaches a from the negative is plus or negative infinity, or the limit as x approaches a period is equal to positive or negative infinity. So if there's a vertical asymptote, vertical, then you know that the limit must be infinity as you approach from the left or the right or both. Identify the equations for the vertical asymptotes for example 4. Vertical asymptote, what's the equation for a vertical line? X equals or Y equals? X equals. This is my vertical asymptote. What's the equation? X equals 0. Look at the next one. Vertical asymptote through. Yep, and as you can see, that's where it's undefined in the denominator. X equals 1. If you don't like the notes, burn them. I'm just saying, you know, they're just an example of notes. You can always just make your own notes if you don't like what you have. So, here's your assignment. Burn the book. Oh, they're so destructive. What got in you today? There you go. 2.2, page 79, 4 through 9, and 19 through 22. Oh, you don't have books yet. Okay. I'll get you books.